Hello, my name is Juan Esteban San Martinez. I am from 10th grade, and this is my reaction. The talks are a conference on topics that are worthy of dissemination, such as a technological advance or educational topics. Today we are going to see the TED Talk about the Spider-Man technology and how science managed to recreate the web.
Fascinating creatures. And their webs are almost perfect. They're strong
Totally, totally agree. Spiders are amazing.
and elastic at the same time. The most durable material we know and almost entirely sterile.
Of course, it's natural.
Since the 1980s, people have tried to manufacture spider silk in the lab, without success. But this man did succeed, Thomas Scheibel.
What? How is possible?
The basic idea was simple.
Oh, they're going to explain what research.
From the genetic material of the spider, copy the
Whoa, what beauty creatures and beautiful. The one on this side looks a lot like the one I have in my garden. Although obviously is the European version. Is this?
More than 48,000 species around the world nowadays. They live in different areas of the world and they produce different spider webs. This is what we're interested in. Most of you ask probably the question, aren't spiders dangerous? Well, I have a clear answer to that. I found this sign in Australia that clearly indicates that in
What is that question? Of course, I always have spiders in my garden. They are very friendly.
2013, almost 45,000 people died by cancer, but 0 incidents occurred with spiders. And this is intriguing because Australia is known for the most venomous and most toxic animals.
Although, is that a differ the spider I have in my garden is one the most poisonous in the world. Is it a pet spider?
Also, most toxic spiders in the world. My interest is in spider webs. Spiders are perfect predators and they use spider silk for hunting prey. This is fascinating because spider silk developed over millions of years to be mechanically one of the most robust materials in the world. On the other hand, you
That the web has regenerative properties.
can actually take a spider web and put it on the wounds. This is known since more than 2,000 years that you can use a spider web as a wound closure device.
I don't think that for so many years. I only create that this was done by the pain sense.
So can we now use spiders as silk producers? You might say, of course. But the real answer is, unfortunately, no, because most spiders are cannibalistic, which means if we bring them together,
That is true. In myself, I have seen it in the garden. I really said that among the same of their space they are not killed. But if they are of different species that are killed.
in one farm or in one box, they start to eat each other. And then we just have one surviving spider. On the other hand, in captivity, spiders lose the ability to make high quality.
Again, I differ. because in my experience, my spider continues to produce the same quality as before because I don't have her incomplete cavity on the in the garden. She feeds herself and I give her food when I can.
Silk. The reason is we are feeding the spiders and therefore there is no need to get high quality silk webs to hunt prey. So how can we access now this fascinating spider silk?
Surprise me.
If we cannot use the spiders as a producer, what can we do? 20 years ago, we developed a biotechnological process.
20 years? So long?
Which we nowadays call the Spider-Man technology. Because we take information from the spider, we actually identify the genes, and now we have to design these genes in order to make them usable in what we call
our Lego bricks.
A recombinant process. What is a recombinant process? We take the genetic information, we design it, we engineer it, and then we introduce that with a transporter into a host organism, which in our case is a bacterium.
Wow, with bacterium?
And the bacteria can now produce tons of spider silk proteins. 20 years after this development, now real products made of spider silk are available. There are cosmetic products like skin care or hair care products.
What? That is to say we use spiderweb products?
And there's textiles like armrests for watches. Of course, mechanical properties are really outstanding and very intriguing for a lot of applications. Now I would like to draw your attention.
Biomedical? Like regeneration for wounds?
And to the biomedical aspects of spider silk. I would like to take a detour because I would like to talk about biofilms. Nowadays, we have to deal with a lot of pathogens that we have in our respiratory system or in the intestine. If we have there the wrong microbes, they might form a so-called biofilm, which is a huge colony that protects itself with a coverage of sugars. And this coverage actually prevents antibiotics to reach the germs, the microbes, and therefore they get resistant. How can we prevent now biofilm formation if antibiotics are not active anymore? This can be done to so-called nanostructured surfaces. And here, spider silk has really outstanding properties because by nature, the surface structure of silk is nanostructured.
Nanostructured is awesome.
I personally am so impressed by the properties of spider silk because spider silk performs very well in a human tissue. Human body cells can grow on silk without any problems, and therefore spider silk is a perfect scaffold.
That is to say, it helps cells regenerate?
For human body cells to generate a new tissue. In combination with the repellency of pathogens, that gives spider silk a bioselective property. And this makes it really a standalone material for future medical applications. Spider silk allows human tissue to grow and repels all the pathogens.
Wow, is to say that it helps the cells heal and no interviruses of bacterium at that same time?
Without the need of antibiotics and without causing resistances against antibiotics. So now this is really changing tides. I'm fascinated that we can use the blueprint given by the spiders. We can take all the information of natural spider genes. We can design new materials in a biotechnological process, our Spider-Man technology. And then we can process these materials into applications. We can nowadays use spider silk materials for skin regeneration. We can actually heal broken nerves. If we have a heart attack, heart muscle
Oh, that makes more sense.
tissue dies, and heart muscle cells cannot regenerate.
Do not regenerate?
So they need external support. Without any help,
This left me imprisoned.
there is a scar inside the heart which actually has a huge impact on the future function. Therefore, even if you survive a heart attack, the heart cannot beat as good as before. We would like to solve this problem by removing the scar tissue with newly generated heart muscle tissue. And for that we need spider silk,
Oh my
because
God.
we can 3D print spider silk scaffolds and we can implement heart muscle cells directly in the printing process. This is what we call biofabrication.
Our real cells look very different from how imaginated them.
In this video, you see printed spider silk scaffolds with heart muscle cells. The heart muscle cells have the possibility to beat on their own, and they synchronize
Oh, that makes more sense.
within the first 2 to 3 days. In the video, you can see it after 55 days of culture in the lab. For us, this is a promise for the future, because this highlights that we can use spider silk-based heart muscle tissue for future applications, and maybe we can really repair a broken heart.
Conclusion. It is impressive. The properties of spiderweb, both is a mechanical resistance and medicine. How can this silk regenerate every type in tissue in your body without problem, including the heart cells, which are very important? I want today get to exchange this scientific advance. Bye.